Hi guys, Mr. Bennett again. Today we're just going to refresh our minds about what we have to do in these sort of questions. So, typical projectile motion question has a number of steps to go through. So, not always does it ask you to do this, but generally the first step that you always will have to do is actually go through and find the vertical and the horizontal initial components of velocity. Alright, the second step normally asks you to find the time of flight, and we will always use the SV formula to do that, unless sometimes there are occasions where it will give you the horizontal distance and some other information, so you might use that formula, but generally it's the first one. Step 3 would normally find the range using our SH formula over here with our T. And then step 4 might be to find the time, the velocity at any particular time. Now, quite often the circumstance that we've seen so far have been it's travelling downwards, but it could be actually travelling upwards as well. So it just matters that the only thing that you have to do for that is to find the final velocity of our particular object at the time that you're trying to work that out. Alright, so and the last thing that you'll generally get asked to do will be to find the maximum height. Now remember, the steps to do there is to find the time taken to get to the top. We know here that the vertical velocity is in fact equal to 0 there, and we know our initial velocity, so we could use this particular formula over here to work out our time of flight. And once we know our time of flight, then we can put that into our SV formula, and that will allow us to work out how high it is. Now in this particular case, you need to understand that if you're going to launch from a particular height to another height, then you need to take that original height that you're launching from above the ground into account when you're working that out. Now, my favourite sport is in fact golf. You know I'm a very keen golfer, so I'm just going to go through an example looking at a golf scenario. So here what we're doing is we're going to be launching a golf ball from a tee spot which is 5 metres above the ground from sea level, and it's going to an elevated green which is 20 metres above the ground. Alright, so if I'm launching with my, let's say, a 7-iron, launching at 40 degrees above the horizontal, and then I'm going to be launching at a velocity of 80 metres per second, I want to know if my ball is going to actually land on the green. Alright, that's the sort of question that you might get. So let's just go through the parts of that might be important. So step 1 requires us to work out the horizontal and vertical velocity. Now, in terms of working your vertical velocity out, we use our V sine theta, and so therefore that works out to be 51.4 metres per second. And to work out our horizontal components, we use our V cosine theta, and so that works out to be 61.3 using that formula. So even if it doesn't ask you to find that, you can't actually work out your time of flight without working those two things out. Alright, step 2 is to find your time of flight. Now, because we're going from 5 metres up to 20 metres, that is in fact a positive displacement, vertical displacement. The key thing there, once we've done that, is we need to bring this across to our the other side. So this comes across over here, and so therefore that now becomes equal to minus 15. Now that's a common mistake that people will make when they're doing this type of question. This here we need to put into our graphics calculator, and you'll find using that, whichever way you want to do it, whether you want to graph it or use the polysim, you'll get a time of flight of 10.1 seconds. To work out its range, right, so it's travelling horizontally at 61.3 metres per second, and it's in the air for 10.1 seconds, and so therefore we've got a horizontal range of 619.1. Now you can tell I've just made this question up because there's no way I could hit a 7-iron that far. I'd be pretty happy if that was about 150 metres. So that's the problem when you make questions up. You don't always get it right. So you get the idea though, the mathematics doesn't quite work out with what we're expecting, but you'll see that the process is the important bit. if I want to find the velocity of the ball after 3 seconds, then all I do is I use my V formula. My original velocity is in fact 51.4. It's minus 9.8 times by the time. So therefore it's going to be moving upwards at a velocity of 22 meters per second. Remember, its horizontal velocity always stays constant. So we know that's going to be 61.3 meters per second. So therefore, if I use Pythag over here to find my velocity, I put in my 22, I put in my 61.3, and that gives me a final velocity of 65.1 meters per second. To work out my angle, I need to then basically say it's my opposite, which is my vertical velocity over my horizontal velocity, and it's inverse tan of that. So I can say my velocity is in fact 65.1 meters per second at 20 degrees above the horizontal. Now, how high will my ball go? Now that might be important as a golfer to know that that particular club I can hit over a tree. So when I'm starting step 5, the maximum height that I'm going to get there, I need to work out how long it's going to take to get to its maximum height. So that means that I need to use the fact that my final velocity there is 0. I know my original vertical velocity is going to be 51.4, so if I'm using that formula, I can work out my time of flight to be, in fact, 5.2 seconds. Alright, so once I've got that time of flight to get to the top, I then put in my information into my SV formula, put in my original vertical velocity, my initial vertical velocity, put the time in there. Remember, it's half of gravity, negative 4.9. Put the time in there again and we square that. So it's going to go 134.8 meters high. Remembering my maximum height, how I have to add on my 5 meters where it starts from, and that's going to give me my final height of 139.8 meters high. Alright, so that there obviously is not going to be a very realistic question, but certainly the formulas work and hopefully you understand that. Right, so we'll go through another question in a little while, so I'll see you for now.